So this will be the first section of notes on Chapter 4, Section 2, where you'll be either given a triangle or given one of the trig functions, and then you'll be asked to evaluate all of the other trig functions out of the 6 total. The first thing I wanted to reiterate, if you weren't familiar with this symbol, this is a Greek letter, so it's the kind of symbol you'll see in fraternities and sororities at college. So this specific one is called theta, and it's most commonly used to represent an unknown angle. So when we have a triangle set up, if we're either trying to refer to one specific angle in it, or if we're saying we don't know what that angle is, this is the variable we usually use for that. So first, looking at the triangles, I'd like to repeat that when you have an angle given, so here's our theta, everything's going to be in reference to this angle. The opposite side, out of the 3 sides of our triangle, the opposite is going to be the one that's not touching that angle. These two are both touching it, so this side, that's across from theta, will be the opposite side. Then there's the right angle. They don't have the square symbol marked in here, but you can tell just by looking at the size of the gaps on the lines there that this is the right angle here. So across from that one will be the hypotenuse. Same idea. There's a right angle. This side is touching it. This side is touching it. So the side that's not touching it is the one that we call the hypotenuse. It's always directly across from the right angle. And then the other term we use is the adjacent side of a triangle. So going back to our angle in this triangle, which is theta that we're basing everything on, there are 2 sides that are touching it, so both of them could be considered adjacent, but since this is the one that's across from the right angle, we always call it the hypotenuse, which means this is the other side that's touching the angle. So just make sure you always distinguish between the hypotenuse side that's touching theta and then the one that's not the hypotenuse. That's the one that you'll call adjacent. So we already did a little bit of a review on the rules first. So TOA, where we're saying SOHCAHTOA. Use some system, whatever system works for you, to help you remember that sine is opposite side over hypotenuse. So if you have an angle, you would know to do this length divided by this length, and that would be what sine of that angle equals. For cosine of theta, you would be doing this length divided by this length, adjacent over hypotenuse. And for tangent, you'll be doing the opposite side over the adjacent side. So from your angle, it'll be the side opposite divided by the side adjacent. Those 3 functions you should be familiar with from geometry. You might not have used these before, but they are simply the reciprocals of the sine, cosine, and tangent function. By reciprocal, I just mean it flips what's in the numerator and the denominator. So make sure you know that sine and cosecant are reciprocals. So instead of opposite over hypotenuse, it's hypotenuse over opposite. Then you need to know that cosine and secant are reciprocals. So instead of adjacent over hypotenuse, it becomes hypotenuse over adjacent. And then the last and easiest pair to remember is the tangent-cotangent pair. So opposite over adjacent becomes adjacent over opposite. So the best thing to do on these questions is evaluate the sine, cosine, and tangent ones normally. And then you can just flip those fractions upside down to evaluate the other 3. You don't have to go back to the triangle and try to redo things. However, sometimes when you flip those fractions upside down, it will cause a situation to happen like putting a radical in the denominator of your new fraction. So be very careful about that, because if the radical was on top for sine, that's fine. But when you flip it upside down, you'll have to rationalize that. You have to get rid of the square root if it's in the bottom of your fraction. So sometimes there might be a little bit of extra work caused by things like that. The trick I always use to remember which ones were reciprocal pairs is that you have an S paired with a C. As long as you remember that, sine and cosecant will be paired, and then cosine and secant will be paired. You should already be familiar with these 3, so I would hope that you wouldn't pair sine and cosine for the reciprocals. Those are the different trig functions that we focus on. So sine with cosecant, one starts with an S, one starts with a C, and then the other way around, cosine starts with a C, secant starts with an S. Tangent and cotangent, people usually do pretty well with. So let's look at a couple of our examples. So the first type of example you'll have is going to give you a right triangle, and they will define an angle theta that everything will be based on in terms of the opposite, adjacent, and hypotenuse. And then they're going to ask you to evaluate all 6 of those trig functions, the sine, cosine, tangent, this cosecant, secant, and cotangent. So just make sure that you remember the relationships for each of the sides. So the first one we're going to do here is going to be sine of theta. And from our angle, that's the opposite side, so 3, divided by the hypotenuse, 5. Well, I just write the fraction 3/5. There's no simplifying or anything for me to do there. Next, we'll write cosine of theta. Going back to our angle, that's the adjacent side. Make sure out of the two sides that are touching theta, don't use the one that's across from the right angle. So that's going to be 4 divided by 5. It may help you to remember that the hypotenuse should always be the biggest side out of the ones available as well. It should always be the biggest side. So my cosine relationship is 4 divided by 5. And then lastly, we have tangent of theta, which is going to equal opposite over adjacent. So 3 divided by 4. And again, those rules are just coming from what we have here on the table, the opposite hypotenuse, and opposite adjacent. So now that that part's done, it's fairly easy to go through and list out cosecant of theta, secant of theta, and cotangent of theta, because I'm just going to take the fractions I already wrote and flip them upside down. There's nothing wrong with me just writing 5 over 3. For cosine, the reciprocal is secant, so instead of writing 4 over 5, flip it upside down and write 5 over 4. I'm not having any of those problems I was talking about where I might end up with a radical in the bottom, so I have to rationalize it, so this is fine. And then cotangent, if you flip 3 over 4 upside down, you're going to have 4 over 3. Now, one kind of twist that they might give you on one of these shapes is you may be missing one of the sides. And if that's the case, just remember that you can use Pythagorean theorem to find whichever one you don't have. So whether you're missing one of the sides or the hypotenuse, just use the rule a squared plus b squared equals c squared. Solve for that missing side first, and then you can go through and actually list the 6 trig functions. Now our last example is giving us one of the trig functions, and they'll give you different ones. It's not always going to be sine that they give you. You just have to remember the rule for each of them. They tell us to assume that theta is an acute angle. In case you've forgotten what an acute angle is, that just means that the angle is less than 90 degrees. So we're going to have a triangle that we should be able to draw out of the given information. And then we're going to have a theta in there somewhere, and there will be a right angle. So however you draw your triangle, it's not going to matter too much. Just make sure it's a right triangle, because they are specifying right triangle, otherwise you couldn't assume that. But then for sine, I know that this must be the opposite side, and this must be the hypotenuse, because sine equals opposite of hypotenuse. So from wherever I located the theta, I need to put across from that side, or across from that angle, I need to put a side of 5. And then for the hypotenuse, so across from the right angle, I need to put the 6. Like I said, sometimes we don't have all 3 of our sides for the triangle given to us. So we're going to have to use the Pythagorean theorem to find the missing value. So I'm going to write a squared plus 5 squared equals c squared. Most important thing on setting up your Pythagorean theorem is that the sides have to be the a and the b value, and the one that's by itself on the other side, that has to be the hypotenuse. It has to be the one across from the right angle. So I'm just going to solve this value here. Now I have a squared plus 25 equals 36, which means a squared equals, you're subtracting from both sides, so I'm going to have 11. And then that gives me a side value of the square root of 11. So they're not always going to come out to pretty numbers. You do want to leave this in the radical form. That's whenever they say an exact answer, they mean that they want you to leave things as fractions and radicals. Do not change them to decimals in those cases. Well, now that we have the 3 sides of the triangle, we can go through and start writing out what sine, cosine, and tangent should equal. So sine of theta is going to equal opposite over hypotenuse. They actually already gave us that one, so that should be a free answer. Cosine is going to equal that new side we just found, which was square root of 11, and we're going to divide that by the 6. No simplifying to do on that, that's fine. For opposite over adjacent, this is where the problems are going to start to come in. I'm going to have 5 divided by the square root of 11. I need to rationalize this answer though. So I'm going to have to multiply the top and the bottom of the fraction by that radical. That way I can write my answer as 5 times the square root of 11 over, whenever you have square root of a number times square root of a number, if it's the same value, square root of 5 times square root of 5, square root of 3 times square root of 3, whatever you multiply, it's just going to be the number inside of the radical. So square root of x times square root of x is x. So in this case, square root of 11 times square root of 11 is 11. That can't be reduced anymore, so that answer is done. That's our tangent of theta answer. Then we're going to go through and we're going to list the other three trig functions, the reciprocal ones. So I'm going to have cosecant of theta, the reciprocal of 5 over 6, and then secant of theta. Again, this one's going to cause that problem with needing to rationalize, because now I'm going to have the square root in the bottom. So 6 over the square root of 11, which means you need to multiply top and bottom by square root of 11 over square root of 11. So the answer for secant will be 6 root 11 over 11. And then the last one is cotangent of theta. The good news on this, since it wasn't rationalized before, when I flip it upside down, it will be in an appropriate form. So now I'm going to have square root of 11 over 5, and I don't have to do anything extra to that one. So there we have our 6 trig function answers all listed out. That's all for the notes today.